Now welcome back again. So this time around, I want to look at another test called two-way repeated measure, otherwise known as two-way repeated ANOVA. Two-way repeated measure or two-way repeated ANOVA. Now, this particular one is a little bit technical because it contains more than two dependent groups in two categories. We have various data in such form. The meaning actually is that the repeated measure ANOVA are generally used for analyzing data where same subjects are measured more than twice. Measure the first time, second time, and third time. The same specimen, the same subject. Alright? Now, if you remember, okay, now this test is also referred to as a within subject. Okay, we call it within subject ANOVA. So the within subject term means that the same individuals have measured on the same outcome variable under different time points or different conditions. For example, maybe we want to have a measure. We want to have a measure of 12 individuals, for example, self-esteem. Okay, yeah, we measure their self-esteem score. Okay, which is the dependent variable now, or the outcome, on 3 time points during the specific diet to determine whether their self-esteem improved. Okay, maybe time 1, time 2, time 3. Maybe you can say maybe beginning, medium, and end. So depend on how you want to group the timing. Okay, so we have T1, T2, T3. Okay, you can see here based on control and diet. Okay, you can see T1, T2, T3 here. Different time interval. All right, so we have a beginning of time, we have a middle, we have a end. So can just equal it T1, T2, T3. No, if you remember, this is just an extension of a paired t-test. Yes. If you remember paired t-test the other time, which we discussed, we should do with one numerical variable and one paired group. Okay, the same subject was measured twice. For example, we did with maybe there was a diet program have effect on the body weight, for example. If you remember then, okay, but body weight would happen to be the dependent variable there. Okay, so we have the score of dependent variable which you have. So we now look at only one pair group. So we are measured twice, first time, second time. We have before and after. So in this kind now we have before, within, and after. So that or in between and after. So this is just a section of peer groups, of peer t-tests rather. All right. So we want to say, okay, do vacations have impact on people's stress level? That is a peer t-test. So you mention the same people first time. Okay, the same people PB were measured first time. At the same time, they come back another time after a few days or a few weeks or months. You mention their PB again. So see after they have returned back to the vacation rather. So you measure again. So you are looking at if the stress, the vacation they went for have any impact on the stress level. Maybe by the time they came back, maybe the stress has reduced. So which means vacation have impact on it. So vacation happen to be the factor here, the factor. All right, so the same thing applicable to this kind of two-way repeated ANOVA or repeated measure, whereby you have the same individual, 12 individual here. This individual now was measured first time on the treatment on this time interval. Okay, T1, we call it T1. Look at the score. Then the same individual was measured again. Okay, this first set. Okay, for control, both control and diet. For the first set, so same individual again, control and diet. for the second set. Okay, the same individual was repeated again for both. Then the same individual was repeated again third time for both. You can see this self-esteem score. This is different time interval. This is the diet treatment. Call it treatment. You have control and diet. So treatment. So this is example of a data set for such repeated two-way repeated ANOVA. So this one is, it can be easily done in past. So this particular treatment and time, they are both called factors. In past, we call them factor A, factor B. Here we have two factors here, right? So how are they doing on the score on this dependent variable? How are they doing? And when each of them, and also when they are interacted. So I want to look at it now. So let's see. Let's copy this. Let's copy this. Only this to past. All right. Don't forget this particular one is a factor. This is a factor. And this is a factor. Don't forget we have three factors now. All right. We have factor A and B. This factor A and B. All right. But we have three groups. So let me be very clear. We have three groups for two factors. Our major factor is factor A, factor B. But this is also a group. So three of them are groups. All right. Because we are dealing with them in past. So past see them as all of them as groups. For this factor A, factor B, we are trying to look at. So you see this and this are the main factors. While these individuals are also groups, but they are not factors. These are the two factors we have. All right. So let's copy them now and to pass. All right. So we have them in pass already. So ready to. All right, so now we have. I'm making this one. This one is group. This one is group. This one is group. Don't forget, you must change your to group. Don't forget the way I did last time. Okay. So just come here, open this place for ID, choose group here. Okay. Do that for the three of them apart from score, which is our continuous variable or dependent variable. Okay. So now you have to select all of them to compute. To compute here. So just go to univariate, ANOVA, go to repeated measure. Okay, this one. Click on it. You can see here. Okay, we have a factor A. The factor A is actually, look at it. Factor A is treatment. Factor B is time. All right. So factor A, what is doing? Factor A is significant, highly on the score. Factor B on the score is not significant. All right. That is a time. Then when they are when they interacted, A and B, all right, they are significant. So you can see that. So this is majorly what you just need, all right, and that is that is all. So this is just a graph of the factor for factor A, all right. So you can easily interpret this very easily, all right. It's very simple to interpret. So you can interpret based on the what you discovered or observe in each factor. All right. So that you just have to compute two-way repeated measure in past. So you can see how simple it is. All right. So I hope you can be able to interpret it. I've done this one in R before. In case you don't understand, you can go and check my R. How it is interpreted, even though the result may be different, but you can understand the interpretation properly there. All right. Thank you so much. I'll see you in the next class.